mole can be related to a couple of different things, right? So give me one of the things that it can be related to.
Volume.
All right, first one I heard was volume. I did hear another one. We'll get that one next. So we can relate the mole to volume. How many of either? Like, give me some numbers.
2.24 liters.
You mean 22.4 liters?
Yeah.
Okay, 22.4 liters is 1 mole. And this is called molar volume. And you are going to need, to remember this number because on the test I'm not giving it to you. All right, I heard another one. I heard somebody say mass, right?
Yeah.
All right, and that's called molar mass. And how do we find, was there a number for molar mass? Not a known single number. We have multiple numbers. So how do we find this?
Adding up all the atomic masses.
Add up all the atomic masses for the formula. How about that? So an example might be Na2CO3. What would we do with that? Break it up. All right, so Na, how many Nas? 2. How many Cs? 1. How many Os?
3.
Okay, and then what's the next number we're going to use? The molar mass. So Na is 23, C is 12, and O is 16. And we're going to do this math. I'm still kind of tired. And if you did the math, you would get 106 grams of Na2CO3 equals 1 mole of that same substance. Okay, so that is how you find the mass for any substance on and relate it to mole. Sorry, if it gets blurry, let me know. All right, what's the third thing that moles can be? Avogadro's number of particles. All right, so particles, and we know that this is Avogadro's number. It's not Avogadro's hashtag. Avogadro's number. And what is Avogadro's number? 10 to the 23rd. And this is equal to, what are the units that particles can be? Atoms, ions, molecules, formula units. Okay. This is a number that you're going to need to commit to your brain as well. So you need to know the molar volume and you need to know Avogadro's number. This is not a number you can memorize because it's always going to be something you're going to have to calculate. All right. Now, if you notice that these are all double-headed arrows, if I'm saying to you, all right, we have 50 grams of something and I want to know how many liters of it, I can go and follow this path over to liters. But if I follow the path, I have to stop at moles in between. So I would go from grams to moles and then moles to volume. Let me show you an example. If we were to do, let's do that 50 grams thing. So 50 grams of, we'll do water, it's easy. 50 grams of water is how many molecules? Okay. 50 grams of water is how many molecules? We're going grams to molecules in this problem. Is there a single arrow that goes grams to molecules? No. I have grams over here and I have molecules over here. So I have to go grams to what in between? Grams to moles and then moles to molecules. All right, let's do that. So 50 grams of water is the starting number from the problem. We put that over 1, right? Okay. What unit goes on the bottom of the next fraction? What unit goes on the bottom of the next fraction to cancel? Grams. Grams of water. We can find the number of grams of water equaling 1 mole by doing the molar mass. Can I do it real quick? You guys don't need like a refresher, do you? Okay, so 2 H's, 1 O. That's 18 grams. All right, so it's 18 grams equals 1 mole of water. Let's check our units and make sure that they're canceling. We have grams of water here, grams of water there. They cancel. I have moles of water. Is that what I'm asked to find? No, I was asked to find molecules. So I'm going to do another fraction. What unit goes on the bottom of the next fraction? Mole of water. So how do I relate moles to molecules? Yeah, Avogadro's number. So I'm going to use this road, if you will. I'm going to go moles to Avogadro's number. And I'm going to plug those in. So 1 mole, 6.02 times 10 to the 23rd molecules of water. Okay, do my units cancel? Yep, and I've got molecules of water, which is what I was looking for. All right, let's do this on the calculator. Remember, when you're doing the scientific notation, you have to be careful. So we're going to take 50 divided by the 18 times 6.02. Remember, you're doing the exponent key. So second EE 23, and you get 1.67 times 10 to the 24th. And this is molecules of water. All right, any questions?